Differential equations, we are finishing 4.4 day 2. You could see at the end of the first video, we're trying to find what these constants are, and it's an initial value problem. And as I said before, you've got two initial values, as you can see at the top of the screen here. We've done some work plugging in our first piece of information. We need to take a derivative though. Y prime, well, wow, we're going to really very quickly use that chain rule, right? You're going to take the derivative of cosine and get negative sine, but the chain rule means a 2 comes out. So we'll get a minus 2c1 sine of 2x. And then we're going to have the chain rule right here just as well. The derivative of sine is cosine, but out comes a 2. So we'll have a 2c2 cosine of 2x. The derivative of 1/2 is 0. But you can see, we had y prime of pi over 8 equals a 2. What does that mean? Well, our y prime equals 2, and our x is equal to pi over 8. And we saw this earlier, plugging in that pi over 8. 2 times pi over 8 is pi over 4, isn't it? And, we know what sine and cosine of pi over 4 are. That's root 2 over 2. So we've got this negative 2c1. Here's a root 2 over 2. Here's a 2c2, another root 2 over 2. And dare I say it, I think you can see immediately, you can see the 2's here are going to cancel out. So we're well on our way where we need to go here. We can say, well, here's our 2, and I'm going to say negative root 2c1. Over here we'll have a root 2c2. And I'm just bringing this up because, look, we had from, as you saw in the video at the start, we had this work, and you can see this is perfectly set up. When you go back to our first initial condition, you can see this is perfectly set up right now to do elimination. I'm just going to recopy this equation right here, because you can see immediately what's about to happen. We can add these two together, and thankfully when we do that, we're going to get these terms to cancel out. 2 and 2 adds up to a 4, and this would be a 2 root 2 c2. And tell you what, we can do something a little bit different. This can look a little surprising. I like to show geometry students this too. You don't always have to wind up dividing here. You can multiply, and this would become a 4 root 2. This is a 2 times 2. That's a 4. So all of a sudden you divide by your 4, and c2 is radical 2. So that's rather nice, and we're able to work that out very quickly. But now, check this out. If we just recopied that first equation that we had for the initial condition, this thing right here, if we were to plug in our c2 now, we have root 2 times root 2. Well, root 2 times root 2 is a 2, isn't it? And when I subtract a 2 from both sides, I get 0. And wow, all of a sudden you can see C1 is 0. This is really worth talking about. This is really worth talking about. In initial value problems, please hear this loud and clear, you could get a constant to equal 0. What bothers kids, and I think you can see why it bothers kids, they're going to say, wait just a minute. If C1 were to equal 0, like you just saw here, one of those trig functions is going to disappear. And guys, that's perfectly okay. So as we're finishing this up, I just wanted to real quickly bring that up to everybody, because I know that's an issue where kids will double check their work sometimes. They'll almost think, wow, is that really okay to have 0 right here and cancel that out? Indeed it is. You don't have a cosine of 2x for your final answer for this initial value problem. You have radical 2 sine of 2x minus a half. And that wraps up 4.4, day 2.